Good day. This is Module 2, and I will discuss additional vector operations focusing on direction angles and direction cosines. So we have here the definition of direction angles and direction cosines. So it says here, the direction angles alpha, beta, and gamma of a vector v equals ai plus bj plus ck are defined as follows. Angle alpha, which we can locate it here, is the angle between vector v and the positive x-axis. So we have here the angle alpha is between 0 to pi and equal to this angle 0 to pi. Then the other direction angle is angle beta. It is the angle between vector v and the positive y-axis. So if we're going to locate here, this is your vector v, and we have here the angle beta as defined as the angle between your vector v and the positive y-axis. Take note that angle beta can be somewhere rather from 0 to pi or between or rather equal to 0 to pi. Then we have the angle gamma. This is the angle gamma. It is the angle between the vector v and the positive z-axis. And the measurement of angle gamma can be anywhere from 0 to pi. It can also be equal to 0 or equal to pi. So we have here the definition on the formula of these direction angles. So in finding angle alpha, we make use of the formula cosine alpha equals A over magnitude of V, where A is the first component of the vector V. Then in defining angle beta, it is cosine beta equals B over magnitude of V, where B here is the second component of your vector V. Then in defining angle gamma, so we can have it cosine gamma equals C over magnitude of V, where C is the third component of the vector V. Then we have here the corresponding identity that if we have cosine squared alpha plus cosine squared beta plus cosine squared y, this should be equal to 1. It's like also relating it to the sum of the three angles in a triangle is equal to 180 degrees. But this is different. No, it's just a comparison of the given equation here to the theorem or to the law that any three angles, the sum of these three angles in a triangle is equal to 180 degrees. So let us have this example. So we have here find the direction cosines of the given vector v equals 3i minus 2j minus ck. Then we have here another example. Find the direction angles of the vector represented by the point P with coordinates 1, negative 1, 0, and point Q with coordinates 3, 4, 5. So let us work first on the first problem. We have here find the direction cosines of v equals 3i minus 2j minus 6k. Okay, so solving now for this problem number 4, let's have the given vector v, which is given as 3i minus 2j minus 6k be written in angle bracket notation as 3, negative 2, negative 6. And we have defined a while ago the formula for cosine angle alpha is equal to A over magnitude of V. Let's define also now the magnitude of V. So that means this is equal to the square root of quantity 3 squared plus negative 2 quantity squared plus negative 6 quantity squared. And the result is equal to square root of 49 or equal to 7. So in defining now the direction cosines, so cosine alpha is one of them, that is now A, which is 3 over 7. Then for the second direction cosine, which is represented by cosine beta, that will be B over magnitude of B. And B here is the second component, which is negative 2 all over magnitude of B is equal to 7. Then lastly, we have here cosine gamma is equal to C over magnitude of B, where this is equal to negative 6. C is the third component on your vector V, and that is all over magnitude of V, which is equal to 7. So these are the direction cosines of the vector V. Then for problem number 5, so we're going to find the direction angles of the vectors, rather vector represented by the points P and Q. So let's define the component of your vector PQ. Let's have this as vector B also. So getting now the components, so let's get the difference of the 2 points starting from the terminal point minus the initial point. So we have 3 minus 1, then 4 minus 1, that's 4 plus 1, then 5 minus 0. And the answer is 2, 5, 5. And in finding now the direction angles, so that is from the formula cosine alpha equals A over magnitude of B. So when we talk about direction angles, it is now alpha, which is now inverse cosine of A over magnitude of B. And that is equal to, let's have arc cosine of A, which is 2. What about magnitude of B? So let's find the magnitude of B, and that is equal to the square root of quantity 2 squared plus quantity 5 squared plus quantity 5 squared. So this gives you the magnitude of B equals 54, square root of 54, and this is also 3 square root of 6. So therefore, the alpha now is arc cosine 2 all over 3 square root of 6. And you can find the value in the calculator. You can use radians, you can use degrees. So let us use degrees, okay? Next, let's have beta. By the way, we can also write in radian. So for beta, this is now arc cosine of B over magnitude of B. And this is now arc cosine of B, which is the second component, 5 all over the magnitude of B, that is 3 square root of 6. So again, find the value in the calculator. This can be in terms of degree or in radians. Then for angle gamma, so we have arc cosine of, we can obtain also from here, that is C over arc cosine of C over magnitude of B. And that is substituting now the values arc cosine of C, which is also 5 all over 3 square root of 6. So again, you can find the value from your calculator in terms of degree or in radian. Just take note that when you do the checking, it should be cosine alpha squared plus cosine beta squared plus cosine gamma squared should be equal to 1. So we can also have this now as, you can input it as for cosine alpha, that is 2 over 3 square root of 6, quantity squared, plus your cosine beta is 5 all over 3 square root of 6, quantity squared, plus you have cosine gamma is, we have it as 5 all over 3 square root of 6, quantity squared. This should be equal to 1. So you may verify the equation if the left member is equal to the right member. So we can see from here that when you are to square each term and then you get the sum, the answer is 54 over 54, which is equal to 1. So this, we have the lesson, an example on direction angles and direction cosines.